Number 5, we want to see if the two functions are inverses. We have h of x is equal to 3x plus 1, and we have k of x is equal to x minus 1 divided by 3. So what we will do, we can plug k into h and h into k and see that we just get x. So we're going to do composition of function. We're going to do h of k of x. So that means I'm going to take this function, plug it in for x everywhere in this function. So that means we have a 3. And then in parentheses for x, we're going to have an x minus 1 divided by 3. And then my plus 1. So what happens is we multiply by 3 and we are also dividing by 3 at the same time, so they divide each other out, leaving me with x minus 1 and then plus 1. Minus 1 and plus 1 cancel out, leaving me with just x. So getting x is a sign that they are inverses. Now we're going to do the reverse order. We're going to do k of h of x. So same thing, I'm going to start with the k. Instead of the x here, it's going to be 3x plus 1. So we're going to have a 3x plus 1, and then the minus 1, all divided by 3. So the plus 1 minus 1 cancel out, leaving us with 3x divided by 3, and 3 divided by 3 gives us x. So they both equal x, so that tells me that they are inverses of each other. So yes, the two functions are inverses. Number 6, same thing, we want to determine if the two functions are inverses. Screw up a little bit. We are given t of x is equal to 5 over x minus 3, and then we have v of x is equal to 3x plus 5 over x. So we're going to do t of v first. I'm going to take this t equation. In the place of x, I'm going to replace 3x plus 5 divided by x, and then the minus 3. So this is what we get. Now this looks messy. We had a fraction in the bottom of this. The way that we get rid of that is look at the common denominator for the numerator. It doesn't have one, it's just 1. The denominator is x. So I'm going to multiply through top and bottom by x. And this is going to give me 5x on the numerator. When I distribute the x to this portion, it's going to cancel out the division by x. That's my whole goal by picking that, to get rid of the fraction. So I'm going to have a 3x plus 5, and then 3x, or minus 3x here, because you do x times is 3, so minus 3x. And so we have a minus 3x, a plus 3x. They will zero each other out. That will leave me with 5x divided by 5, and 5 divided by 5 is 1, which just leaves us with x. So that looks good. And then we're going to do v of t of x. So starting with the v equation, that's going to be 3x. In the place of x is going to be 5 over x minus 3. Plus 5. And then all divided by x, which is going to be 5 over x minus 3. Okay, so again, with these fractions that look a little bit complicated when you got a fraction in the numerator, fraction in the denominator. All we're going to do is look at the common denominator. So x minus 3 is on the bottom, x minus 3 on the bottom. So to fix that, we're going to multiply by x minus 3 on the top and the bottom. It's going to get rid of those fractions for me. So here is what happens. The x minus 3 multiplies times this term. It's going to get rid of the x minus 3 on the bottom, leaving me with 3 times 5, which is 15. And then the x minus 3 times the 5, well, you have to distribute. So 5 times x, and 5 times a minus 3, minus 15. So my numerator is just this, no more fraction. On the denominator, multiply this times this x minus 3, it cancels out, leaving me with just 5 on the bottom. Positive 15 and negative 15, 0 out on the top, leaving me with 5x divided by 5, and that just leaves me with x. So both of them end up being x, so they are inverses of each other. So it says, to verify that t and v are inverses, we must show that t of v of x is equal to x, and v of t of x is equal to x. So this is just going based on the definition. First, it says find t of v. So that's the one we did here. The 5 on the top here, and then in the place of x, 3x plus 5 over x, and then you have the minus 3, so that's this part right there. And then multiply the numerator and denominator by the complex fraction, multiply numerator and denominator of the complex fraction by the LCD of x. Okay, so that's what we did, multiply by x right here, and then we get 5x on the numerator, and this was a minus 3x. Combine like terms, reduce. This was a 5, so they're at this part right here, and that just equals x. And then v of t of x, we're going to plug in the 5 divided by x minus 3. And they want us to write out what that equals. So I'm going to say division bar. Oh, it just says use the same strategy to find v of t. It just equals x. And we just go through the whole process, we got x. And then therefore t and v are inverses.